Hello, and welcome back again to our channel. And today we're going to continue a new topic, and it's going to be on decimal places and significant figures. I know this is a very tricky topic, but it's an all-comprehensive video, so that it will be your go-get-you, so that we can eliminate any form of trickery that is involved in decimal places and significant figures. So we're going to take them one at a time. We'll start with decimal places, and then we move on to significant figures. All right. So come with me. Come with me on this journey. All right. I hope you're doing well, though. I hope you're doing well. Come with me on this journey. So, in this video, we're going to start with decimal places. We're going to start with decimal. We're going to start with decimal places. All right. Now, we can say that a decimal place in a number is that which comes after a decimal point. So decimal places, we always consider a decimal place right after a decimal point. So let's say for example, we have 4.2768. For example, we have this, right, and we are saying that the decimal place comes right after the decimal point. Where's the decimal point? This is our decimal point. That dot there is known as the decimal point. So when we want to talk about decimal places, then we are interested in the numbers that come after. So these numbers, all these numbers, we can say we can call them, we can say they are the decimal places. Okay, so decimal places come right after the decimal point. So don't forget that. We consider it. So this, what it means is that this two here, this first one here, will be the first decimal place. Will be the first decimal place. Why is it the first decimal place? Because it comes right after the decimal point. It comes right after the decimal point. And then the second one here, this one here, the 7, will be the second decimal place. It will be the second decimal place. And why is it the second decimal place? Because it comes right after is the second number that comes right after the decimal point. So right after the decimal point, the first number there will be the first decimal place. The second one will be the second decimal place. But however, and then let's continue. And then when we have, let's say this 6 here, the 6 here will be called the third decimal place, and finally we're going to have this 8 here, the eighth one here, what we call the fourth decimal place, right? However, if the question is asking us to consider the third decimal place of this, so let's say we're going to write it again. Let's imagine we have 4.2768, right? And we want the first decimal place. Okay, we want the first. We want to correct it to one decimal place. Let me put the question well. We want to correct. We are being told to correct to one decimal place. We are correcting it to one decimal place. Now remember, we said that the number that comes right after the decimal point. So we know this is the first decimal place, right? It's our first decimal place. Now, if we want to correct to one decimal place, right after the first decimal place, we want one decimal place, but this is the first decimal place, right? But after the decimal place, is it greater than one? Is this number after? Is it greater than or equal to 5? Is it greater than or equal to 5? Is it greater than? Yes, it is, because 7 is greater than or equal to 5. It's greater than that, and because of that, if yes, we add one. Add one to the first decimal place. So remember, there's a first decimal place, and the question can ask us to correct to one decimal place. So the first decimal place is 2. However, the number right after the first decimal place is 7, is greater than 5. So we add 1 back to the first decimal place, which is 2. So we'll end up getting 4.3, which means we corrected to one decimal place. All right. I hope that one is clear. Let's take it again. Okay, we're going to continue. So we have 4. We say we have 4.2768. For example, we have this, and we're being told to correct to one decimal place, right? One decimal place, and we said that this is our first decimal place, right? But the number right after the first decimal place, after it is what? Is 7, and 7 is greater than 5. So we add one, and then we get 4.3. Okay, we get 4.3, which is one decimal place. All right. Now, if we've been asked to correct to two decimal place, we know that this is our second decimal place, right? But the number after it is 6, and 6 is greater than 5. So we add 1. We add one what to the second decimal place, and that will give us what 8. So our answer becomes 4.28 because it's the second decimal place. It becomes 4.28, which is the second decimal place. Can you see that? So we are correcting the 4.2768 to two decimal places. This is our second decimal place, but the number after it is 6. It's greater than 5. So we add it to that 7, and then we get 4.28. All right. I hope you bring in some clarity. I hope you can understand. You can see what we are doing. Let's imagine we're correcting to 3 decimal places. Can you pause the video and try to see if you can do it? Is it possible? Now here, this is our third decimal place. Why? Because this is the first, this is the second, and this is the third after this dot decimal point. So if this is our third decimal place, the number right after that is 8 and is greater than 5. So we add it to the 6, and then we get 7. So our answer is going to be 4.277, indicating 3 decimal places. Okay, so those are basically the rules that govern. Those are the rules that govern decimal places. So we are going to take some examples and see how we can be working with that. So let's imagine we have another one here. It says 18.58. We're still on decimal places. 18.5843.077, for example, right? We have this, and we are being told to correct. We're correcting to correct to, all right? We're correcting to one decimal place. All right. Now our point. This is our decimal point. Can you see that? This is our decimal point. And if this is our decimal point, the number next to it is our first decimal place. Can you see that? This becomes our first decimal place. We are being told to correct to one decimal place. And if this is our first decimal place, what's the number after? The number after is 8. After is 8. So it's greater than 5. So we add 1. We add 1 to what? The 5. And we end up getting 18.6. So we have 18.6 as our one decimal place. Can you see that? Now let's imagine for 5 decimal places. Let's say we are correcting this. We want to correct this. We want to correct this to 5 decimal places. We want to correct this to 5 decimal places. Now we know that this is our first decimal place, second decimal place, third, fourth, and fifth decimal place. Now, if this is our fifth decimal place, the number after it is 7 and is greater than 5. So we add 1 to the 0, add 1 to 0. And then our answer is going to be 18.58431. And then we've been able to correct it to 5 decimal place. Is that clear? Is that okay? Is that okay? Now let's take a look at another one. Let's say that we are being told to convert. We are converting to convert 2.599. We are converting to the nearest hundredth. To the nearest hundredth. Okay, to the nearest hundred. Now, don't let the wording scare you. Now, when the time we say the 10th is the same as the first decimal place, it's the same as the one decimal place. Okay, if we say 100th, all right. If we say 100, then is the second decimal place, right? We say 100, is the second decimal place. It's 2 decimal places. Like that. If we talk about thousands, correct to the nearest thousand, then we're looking at 3 decimal places. It's the same thing. So if we look at this 2.599, we know for sure that this is our decimal point. Can you see that? Yeah, that's our decimal point. And we know that this is our first decimal place. Can you see the first decimal place? But we are being asked to correct the nearest hundredth. And the nearest hundredth is 2 decimal places. So this will be, the 9 here, will be our what? Second decimal places. This is our first decimal place. This is our first decimal place. And then this is our second decimal place right there. Can you see that? Is our second decimal place. So first decimal place, second decimal place. And then the question we need to ask ourselves, because we are correcting the nearest hundred or two decimal places, the number after it is 9 and is greater than 5. Can you see that? So we add 1. We need to add 1 to the 9, and that will give us 10. 10 added to the 5 will be like 6, all right? So we're going to have, so correcting the nearest hundred is going to be 2.5. It's going to be 2.6. Can you see that? It's going to be 2.6. Why? It's going to be 2.60. Why is it 2.60? Because this one this is our first decimal place, second decimal place. This is the 10th. This is the 100th. But the number after the 100 is this one is greater than 5. So we add 1 to this 9 here. All right? Add 1 to this 9. Now, this whole number here is 59. If you add 1 to it, it will make the whole thing to be 2.60. It will make it 2.60. And that gives us to the nearest hundredth. The nearest hundredth or two decimal places. I hope any form of confusion has been addressed. Any form of confusion has been addressed. Now let's take another question here. Another question here. Let's see whether we can be able to do something about it. Now we have here we are being told to correct. We should correct. We are going to correct 0.00129. The one that's to correct it to the nearest 10,000th. 10,000th, all right? To the nearest 10,000. Now, we said that this is our decimal point. Do you remember that? This is our decimal point, and then this one is our first decimal place. Can you see that? Which is the 10th, all right? This one is our second decimal place, which is our 100th. Can you see that? It's our 100th. This one here is our third decimal place, which is our one, which is our 1,000th. It's our 1,000th. And then this 2 here, is our fourth decimal place, which is 10,000th. All right. Now we're being asked to correct to the 10,000th, and we are this is the fourth decimal place, the 10,000. But the number after it is 9. After that is 9, which is greater than 5. So we're going to add 1, and when we are adding 1, we add 1 to that fourth decimal place. All right. So when we add it to the 2, it's going to give us 3. So the answer is going to be 0.0013. Why? Because this is the 10th, this is the 100, this is the 1,000, and then this is the 10,000. But this one is greater than 5, so we add 1 here, and then we get 0.0013 like this, and that's our 4 decimal places like that. And I hope that brings some kind of some kind of a clarity. So we're going to jump over to significant figures. We're going to jump over to significant figures. I hope decimal places is better. Like you're able to understand decimal places. Let me take one last one for decimal places, and then we go just in case you're having some little doubts. Let's say you have 13.99. The 9 there is 4. 999, and then you have 5 and 7, and we are correcting to 4 decimal places. 4 decimal places. All right, we want to correct to 4. Now this is our decimal point. This is our decimal point. Can you see that? This one is our first DP, our first decimal place. This is second. This is second DP. This is our third decimal place, DP, right here. This is our fourth decimal place. Now, what is the number after this 4 decimal place? It is 5, and it's greater than or equal to 5. So we add 1. We add 1 because it's also equal to 5. We add 1 to that 9. All right, and it changes everything. So remember, we're supposed to have 13.9, the 4 nines, right? And we are going to add 1 to this 9 here. So it's just like 9,999, right? If you're adding 1 to it, what do you get? You're going to get 0, right? It's 10, 0. Remember 1, you put it at 10, 0. Remember 1, you put it in and get the 10, 0. Remember 1, get 10. It's going to be 10,000. Can you see that? Can you see that? So basically, we end up, if we're getting 10,000, this number changes, right? It changes this 13. Can you be able to see that? because we added one, this one will make this 13 to change. So we're going to end up getting 14.0000, like this. Everything is going to change. That one is going to end up adding to this, and then you would have converted into four decimal places beautifully like that. Now let's switch over. We're going to switch over to we're going to switch over to significant figures. We're going to switch over to significant figures. We'll switch over to significant figures. All right. We're going to do some significant figures. Now, in significant figures, we count the actual digits in the number to obtain the required significant figures. All right. So when the number starts with zero, that zero is considered it's not significant. It's insignificant. All right. If the number also comes right after the decimal point, if there's zero, so let's say that a number starts with this. Let me give you an example. Let's say you have 0 point something. This number is not significant. You don't count it as one significant number. You don't count it. Also, if you have, let's say, 7.04, this also is also not significant. All right. So those are the rules. If a zero starts, it's not significant. If the zero comes right after the decimal point, that zero here, this zero here, is not significant. However, if you have, let's say, 7.40, this one here is significant because it's coming in between two non-zero numbers. In between two non-zero numbers. So if it starts with a zero, we don't count that. If the zero comes right after a decimal point, we also don't count that. All right, we also don't count that. So let's say that based on what we just said, let's say that we have this problem here. We are being told to have 0.0099. There are three nines there and five, like this. And we are being told to correct to three sig figs. Okay, we are changing it to three significant figures. Three significant figures, right? Now remember, we said that this, because it starts because zero starts, it's not significant. Not significant. We ignore this number. This one too, we ignore. We also ignore this one as well. And then this becomes our first significant number. Significant number. First one. And then this becomes our second. Can you see that? And then this also becomes our third significant figure. Can you see that? Now, because this is our third, we need to go after that third significant number is 5. And that number is greater than and equal to 5. So we're going to add 1. We need to add 1 here. Because we said this is the first, this second, and this third. And we're being asked to correct to three significant figures. And once we get to the third significant number, we ask the number right after this. And this one is 5. It's greater than or equal to 5. So we add 1 here. All right. And if we are adding 1, all right, if we're adding 1 here, we realize that the 1, this whole thing will become 0, 0. So we end up getting something like 0.01. Can you see? It's going to be 0.0100 was 3 sig fig. So if this one adds to this, remember that's 999, right? It becomes 1,000, right? It becomes 1,000. This 999, when you add 1 to it, even though you're adding 1 to just this 9, it becomes 10. The whole thing here will change. All right, the 999, if you add 1 to it, it becomes 1,000. So once it becomes 1,000, this column becomes 1 because we have 1, 2, 3, 4. 1,000 is 1, 2, 3, 4. Can you see that? 1,000 is 1, 2, 3, 4. If we're adding 1, this is the fourth one. This is the third one, the second one, it is a 1. So the 1 comes into that column. That's why 0.01000. It's supposed to be like this. But they said three significant figures, so we don't need to bring the 0 there. That's why the answer is 0.0100. So that this is not significant. This is also not significant, but this is the first significant number. This is the second, and then this is the third. So we have corrected it into three significant figures. We've corrected it to three significant figures. All right. Now let's try another one. All right. Let's try another one. Let's imagine we have let's say we have 2.406 and we're being told to correct this to five significant figures. Five significant figures. Now, because we are starting with a number, this is a number. This is our first significant number. It's our first sig number. All right, it's significant. Now, this one too is a second significant number. It's significant, regardless of whether the decimal point is here. All right, this is also the third. All right, significant number. This is going to be our fourth. All right, and this is going to be our fifth. All right, fifth significant number. Now, if this is our fifth significant number, right? If this is our fifth significant number, the number after that zero is 6, and that 6 is greater than or equal to 5. And if it's greater than or equal to 5, we need to add 1. So this is our first, second, third, fourth, and fifth number. Here is greater than or equal to 5, so we add 1 here. We add 1 here, and when we do that, we're going to get 332 dot 4 and 1. Can you see that? Dot 4 and 1, and then we put the 5 significant figures beautifully like this. Can you be able to see that? Can you be able to see that? I hope most of the tricks are coming through. Now let's take more. Let's take more. Now let's say that we have 0.037926, and we are correcting this to two sig figs. Two sig figs. All right. Now remember, we said that this is 0, so this is not significant number. It's not. This is also not significant, right? If it comes after the decimal, if a 0 comes after the decimal point, it's not considered important. If it starts before, if it begins the number, it's also not. So that means this is our first significant number, and this is our second. And now the number is our first, this is our second. Now remember, the number after is 9, and it's greater than 5, so we add 1. So this one is greater than 5, so we add 1 here. We add 1 here. And when we do that, we're going to get 0.0. Can you see that? 0.0. 38. We add 1 to this 7, becomes 8. So this becomes 2 sig figs. And you can always check, because this is not counted. This is not. This is also not. And this is our first significant number, and this is our second significant number. So our answer, it remains in 2 sig figs. Now let's continue by taking more examples. Let's say that we have 1712.7294, and we want to correct it to 6 sig figs. We want to correct it to 6 sig figs, right? We want to correct that to 6 sig figs, right? We said that this will count. This one will count as the first one because a number. This is second, third, fourth, fifth, and sixth. Now the number here after the sixth one is greater than 5. It's greater than 5, so we add 1 here. So it becomes 1712.73, and then our answer is in 6 sig figs, or 6s.f. And then we can count and see that this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6, and this is 6, and this is 6. Now let's try this one here. Okay, let's try this one. Let me try this one here. Let's say that we have 0.00300 5, 6, and 7. And we're being told to find the 3SF, 3 significant figures. Now, we said this will not count. So this is not part, this is not part, this is not part. This is our first one. Can you see that? This becomes second because it comes after a number. So we count that. And this is our third. Now, the number after the third, the number after this third is 5, and it's greater than or equal to 5. So we add 1 to the 0. So we're saying that this is 1, this is 2, and this is 3. 3 sig figs. The number after here is 5. Is greater than or equal to 5. So we add 1 here. And when we do that, the answer becomes 0.0030, and then the other 0 becomes 1. And we can see this is our first, this is our second, and this is our third. That significant figure. I hope this really addresses some of the concerns that we have with when it comes to decimal places and significant figures. When it comes to decimal places and significant figures. All right. So I'll end here. But if you haven't yet subscribed to our channel, please do us a favor by subscribing, so that We can grow this family together. If you already subscribed, I want to say a big thank you to you for helping us grow this channel. I'll come to you another time, but when I come back, I'll come with another very relevant video for your consumption. All right, take care and bye.